Hello everyone, welcome to Chemazon-Complete Chemistry. So this is question 37 of the GATE 2022 chemistry paper, which is based on 4 plus 2 cycloaddition reaction. So the very first question that comes to your mind is, what exactly is a 4 plus 2 cycloaddition? And how did I come to know that this is a 4 plus 2 cycloaddition reaction? Because in the question it is not mentioned that it is a cycloaddition reaction. So what exactly is a cycloaddition reaction? There is a compound having two double bonds that is called as a diene, and a compound having a single double bond that is called as a dienophile. So diene and dienophile, this will attack here, pi electrons will come here and will get a 6-membered ring. Okay, double bond. Okay, this is the final product. So this is also called as this is the name reaction, it is also called as Diels-Alder reaction. Okay, why it is called 4 plus 2 cycloaddition? Because in diene there are 4 pi electrons and in dienophile there are 2 pi electrons. That is why 4 plus 2. So this reaction you can see here this is a 4 pi system, that is it has 2 double bonds. Okay, that is 2 plus 2, 4 pi electrons. So from this I came to know that this is a diene. But from this, can you come to know this is a dienophile? There is one double bond, but there are some other groups. So what we have to do, we have to modify this, and this is going to be slightly different from the regular Diels-Alder reaction that we see. So our first important task, what it is to form the dienophile. Formation of the dienophile. That is the first step. Dienophile. A dienophile, or we can say compound having 2 pi system. 2 pi or 2 electron system we can say. So what is given to us is there is silicon. To this silicon there are 3 methyl groups that are attached. Then there is this carbon, double bond CH2. Then we have 2 methyl groups and O, C double bond O, CF3. So now what will happen is this carbon silicon bond, you can see it is a bond between metal and carbon. A metal carbon bond that is similar to bond between carbon and magnesium that we see in Grignard reagent RMgX. So we know in RMgX carbon has a negative charge and metal has a positive charge because it is electropositive, so it can easily donate its electron. Similarly, here what will happen is, here also silicon carbon bond, carbon is more electronegative, so this will withdraw electron towards itself. Okay, what we will have is this negative charge on the carbon, CH2 minus. Okay, and then this CH2 minus, it can attack here and this will go away as a good leaving group. Now why this is a good leaving group? There are two reasons. First is, if you see oxygen negative charge is stabilized by two factors. One, it is stabilized by resonance with the carbonyl group. Okay, so the first reason for the stability of this group is resonance. The second reason you can see it is there are 3 electron withdrawing fluorine groups which will stabilize the negative charge on oxygen by inductive effect, minus I inductive effect. Okay, another third reason that is possible is this carbonyl oxygen, what it can do is it is electron rich, and we know ZnCl2, it is a acid, it is a Lewis acid, so it can easily accept electron. Okay, so this lone pair can easily attack zinc chloride and it is protonated. Okay, when it is protonated like this, positive charge on electronegative atom is even more unstable. This is very unstable. So this process of Lewis acid base reaction, this fastens up or makes this leaving group even more stable. Why? Because greater is the positive charge on an electronegative atom, more will be the tendency of this other oxygen atom to stabilize this carbonyl oxygen via resonance. So because of this Lewis acid base reaction also, this acts as a very good leaving group. Okay, so after the loss of this leaving group, you can see 1, 2 and 3. So there will be a formation of a 3-membered ring. Okay, what I've got is CH2. Here I have double bond CH2. Then a carbon having 2 methyl groups. Okay, like this. So this is the compound that we have got. Now, if you see the normal Diels-Alder reaction, it is a double bond that reacts. But in this case, what will happen is, because of the ring strain of the 3-membered ring, this single bond or sigma bond is going to break. So this sigma bond is going to be the source of 2 electrons. This was the only twist in this question. If you react directly the double bond with the diene, you will not get the correct answer. You will not get the product. The only trick was that there is ring strain. So instead of pi bond, what will react is this sigma bond. Okay, so now what we can do? Now we can carry out our normal Diels-Alder reaction and get the product. Okay, this is a 5-membered ring diene. This is going to react with sigma bond CH2, carbon attached to 2 methyl groups, double bond CH2. So how this reaction takes place? This will attack here. The sigma bond electrons will come here and this will move here. So what we will get is, we will get a 6-membered ring. Okay, how I will get the 6-membered ring? 1, 2, 3, 4, 5 and 6. Okay, you can see this bridge that I'm drawing in yellow. This will be, this I can draw as a, this is a bridge. Okay, so this is a bridge and here there will be formation of the pi bond between 2 and 3. 1, 2, 3, 4, 4, 5 and 6. What else has happened? 5 and 6, here the bond, there is no bond between 5 and 6. 5 and 6, this bond is broken. Okay, and then there is what? There is double bond CH2. Okay, and at carbon 5 you can see there are 2 methyl groups. So methyl, carbon 5, there are 2 methyl groups. So this is the final product. Okay, it is overall, it is not a 6-membered ring. It is how many membered ring? You can see it is 5, 6 and 7. Just because of this numbering, it looks like a 6-membered ring, but it is a total 7-membered ring. So this is going to be the final product. So check the options. Which is the correct answer? The correct answer is this. 7-membered ring is formed. 1, 2, 3, 4, 5, 6. There is a bridge, double bond CH2. So the correct answer is option A. I hope you have understood the solution. Thank you.